Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 11 mathematics, and in this video we'll be having a look at the nature of roots. We'll start off with a brief introduction on what nature of roots are, how do they relate to equations and inequalities, and examples of them. We'll get into details on how to determine the nature of roots exactly, and then we'll have a look at the discriminant and how we could use the discriminant to determine the nature of roots. Without any further ado, let's get into it. In one of our previous videos, we said that we can solve quadratic equations by using the quadratic formula. So we can solve for x in a quadratic equation using the quadratic formula. And these x values that we are solving for, these are called roots. So if they don't say to you solve for x, just know that they could say to you find the roots of the equation. And if they say find the roots of the equation, we're basically talking about the x values. Now, we said that our quadratic formula can be written as negative b plus or minus the square root of b squared minus 4ac divided by 2a. I'm sure by now you're very much familiar with this formula. It's in your information sheet in the exams, and you use it quite frequently, not only in algebra, but also when you are working with functions, inequalities, and even simultaneous equations. Now, we can look at what's underneath the square root sign, and what we actually have here underneath the square root sign is quite interesting. Using the values that we have under the square root sign, we can determine what type of numbers. So we're looking at the type of numbers the x values will be. Notice, for now, we're not exactly interested in what the x values are, but rather the type of numbers. So if you don't know what we're talking about by type of numbers, please check out our previous video on the number system, and I will leave a link to that video in the description below. Please do check it out. Now let's get into the subject of today's video, which is the nature of roots. So we can use nature of roots to determine the type of x values, or the type of roots we would get when we solve for x. We've already spoken about this. In the quadratic formula, we said we use the values underneath the square root sign to determine the nature of roots. So if we can go back to the previous slide, we're talking about the values under the square root sign. And one way we could do that is we can have an expression under the square root sign being called the discriminant. We'll actually look at that in the upcoming slides. So, looking at the discriminant, we can use the discriminant to find the nature of roots. Now, the discriminant is defined as delta equals to b squared minus 4ac. If you can go back to the quadratic formula, we've got x is equals to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now, as we said, this delta is exactly what we have under the square root sign. So I can rewrite the quadratic formula and say x is equals to negative b plus or minus the square root of delta over 2a. For now, we're not so much interested in this equation. Remember, we said we are using our discriminant or delta to determine the type of numbers. Real numbers, rational numbers, irrational numbers, whole numbers, integers. We're not so much interested in exactly what the values are, but rather the type of values that we will get. So, if our delta is negative, or if the discriminant is negative, it means that the roots are non-real. If our discriminant is equals to 0, our roots are real, rational, and equal. If our discriminant is positive, meaning greater than 0, then it is also a perfect square. It means that the roots are real, rational, and unequal. If it's not a perfect square, the roots would be real, irrational, as well as unequal. Now, this was a lot to take in, and most probably you would not remember this from the get-go by just reading through this. So I've prepared a nice diagram for you, and we're actually going to use this diagram quite a lot when looking at the examples, when looking at the questions for solving nature of roots. Take note, we are saying that if delta is negative, our roots are non-real. If delta is equals to 0, our roots are real, rational, and equal. So we only have equal if delta is 0. Please take note of that. So if delta is positive, already we've got real roots and they are unequal. Remember, we're saying this is real because initially, when delta was a negative, we had non-real roots. If delta is not a perfect square, our roots would be real, irrational, and unequal. If delta is a perfect square, we would have real, rational, and unequal. This is a lot said. Let's actually get into some examples and talk about how to apply the nature of roots. So the first question says that we need to discuss the nature of roots of the following equations. Right, let's look at the first one, and let's go to our writing pad and actually have a look at this question. So the question was x squared minus 6x, so this is minus 6x, plus 5 equals to 0. Please take note, we are not solving for x, we are determining the nature of roots. So I can say a is equals to the coefficient of x squared, which is 1, b is equals to the coefficient of x, which is negative c is equals to our constant, which is 5. I can therefore say delta is equals to b squared minus 4ac. Now, when I substitute my values, this is going to be negative 6 squared minus 4 into the value of a is 1, the value of c is 5. This is going to give us 36, and 4 times 5 is 20, so 36 minus 20, this is going to give us something like, let's see, this is 14. Now the question said we need to discuss our nature of roots. Take note that we have a positive number here. So our delta is positive. Our delta is not a perfect square because a 14 is not a perfect square. So let's go back to our diagram and actually see what do we need to do in the event that we get such an expression. So delta is positive, yes. Delta is not a perfect square. It means, therefore, that if I can go back to my writing, my roots are going to be real because it's positive, irrational because it's not a perfect square, then unequal because delta is not equals to 0. I hope that this makes sense. Let's look at the next question. So in our next question, we've got negative 2x squared plus 4x minus 12. Let's look at this one. So we've got here negative 2x squared, let's see, plus 4x minus 12 is equals to 0. We start off by writing the value of a is negative 2, the value of b is positive 4, the value of c is negative 12. So delta is going to be equals to b squared minus 4ac. When we substitute this, the value of b is positive 4 squared. Minus 4 into the value of a is negative 2, the value of c is negative 12. Let's see what happens when we substitute this. So 4 squared is 16. 2 times 12, or should I say negative 2 times negative 12 gives us positive 24. Positive 24 times 4, that's going to give us something like negative 48. Now 16 minus 48, let's just do this on this side. So I'm going to say 48 minus 16. 8 minus 6, this is going to give us 2. Then 4 minus 1 is 3. So our answer here is going to be negative 32. Because the value of delta is negative, let's go back to our little picture again. The value of delta is negative, so the roots are non-real. So let's get back at this and let's conclude, therefore, that the roots are non-real. I hope that this makes sense to you. If you guys are enjoying this and you're learning something, please do give us a like. Please subscribe to the channel. Click on the bell icon so that you will always get an update when we upload new videos, that you never miss anything. Right, let's look at the next question. We've got 6x squared minus 4 is equals to 0. Let's have a look at this. So we've got 6x squared minus 4 is equals to 0. So the value of a is the coefficient of x squared, which is 6. The value of b is the coefficient of x. Since we do not have a term of x, we're going to have the value of b as 0. The value of c is negative 4. So delta is going to be equals to b squared minus 4ac. This is going to give us 0 squared minus 4 into the value of a is 6, and the value of c, that's negative 4. Right, let's see what we get here. This is going to be 0 plus 6 times 4 is 24. Then 24 times 4, that's going to give us 96. Yes. So our answer here is 96. Now notice that delta is positive. Delta is not a perfect square because 96 is not a perfect square. So since it's not a perfect square, when we go back to our diagram, we could see that if delta is greater than 0, which is what we have here, the roots are supposed to be real and unequal, but since it's not a perfect square, we have irrational roots. So coming back to our writing, we're going to say that the roots are real because delta is positive, irrational because delta is not a perfect square, and then unequal because delta is not equals to 0. I hope that this makes sense to you guys. Once again, if you enjoy the content, please give us a thumbs up. Please subscribe to the channel. Alright, let's move on to the next section. Now, these type of questions are good for you to train your ability to answer questions on nature of roots, but these are not the type of questions that they'll ask you in the exam. In an exam, they'll give you the type of questions like these in example 2, where they say to you, for which values of k will this expression have equal roots? Let's go to our diagram, our writing pad, and I'm going to open a new sheet of paper. And let's look at this equation together. So we have got here x squared minus 2x plus 4 is equals to k. The first thing we want to do is to take k to the other side. So we're going to have here x squared minus 2x plus 4 minus k is equals to 0. So the value of a is the coefficient of x squared, which is 1. The value of b is the coefficient of x, which is minus 2. The value of c in this case is going to be 4 minus k. The question asked us, for which values of k will the expression have equal roots? Now, if we go back to our diagram, we said for us to have equal roots, delta must be equals to 0. So we can go back to our writing pad and say, for equal roots, delta must be equals to 0. So I'm going to say here, b squared, which is delta, minus 4ac, is equals to 0. Now I can substitute what I have. Negative 2 squared minus 4 into the value of a is 1. The value of c is 4 minus k. This is going to be equals to 0. Now we can solve for k. So negative 2 squared gives us positive 4. Negative 4 times 1 is negative 4. Negative 4 times positive 4 gives us negative 16. Negative 4 times negative k gives us positive 4k, and this is equals to 0. So 4 minus 16 gives us minus 12, plus 4k is equals to 0. We could take the negative 12 to the other side, and we get 4k is equals to 12. We can divide this side by 4, divide this side by 4. Let's scroll down for some room. This cancels this. The value of k is equals to 3. By so doing, we have answered the question, life is great. And because life is great, let's subscribe to the channel. Right. The next statement says we need to check for where delta will have real roots. So let's go to our writing pad and let's look at this. We are using the same values of a, b, and c that we have up here. So what I'm actually going to do now is let me copy the expression that we have here. So I'm going to copy this and let's paste it down there. That way we can work with the same values without having to waste time rewriting. Okay, the question is asking us for real roots. So let's go to our diagram and let's check under what circumstances do we have real roots. The roots are real when delta is positive. So let's go back to our sheet of paper and we're going to say here, for real roots, the value of delta must be greater than 0. So we could say b squared minus 4ac, which is delta, is greater than 0. The value of b we said is negative 2. So let's substitute negative 2 squared minus 4 into the value of a is 1. The value of c once again is 4 minus k. This is greater than 0. 4 minus 4 into 4 minus k is greater than 0. When we simplify this, we get 4 minus 16 plus 4k, which is greater than 0. This is a terrible k. Let's fix it. Right, we've got 4k like that. We said 4 minus 16, this gives us negative 12. Negative 12 plus 4k is greater than 0. We can take the negative 12 to the other side, and we are going to get 4k is greater than positive 12. Now we can divide by 4 and divide by 4. This will cancel this. We're going to get k is greater than 3, and this is our final answer. Life is great. Right, let's look at the next question. Now we're looking at non-real roots. So, for non-real roots, let's quickly go to our diagram. For non-real roots, we said the delta must be a negative number. So, let's go to our writing pad and let's look at this question again. Now, once again, let me open a new sheet of paper and I'm going to paste the working that we have there. Right, we said for non-real roots, let's just write it here. So, for non-real roots, the value of delta must be less than 0. So, b squared minus 4ac is less than 0. We are going to have negative 2 squared minus 4 into the value of a is 1. The value of c is 4 minus k. This is going to be less than 0. So we are going to have here, this is going to be 4 minus 4 into 4 minus k is less than 0. We're going to have 4 minus 16 plus 4k is less than 0. This is a terrible less than sign. Right. So 4 minus 16, that's going to give us minus 12, plus 4k is less than 0. We could take the minus 12 to the other side. We're going to get 4k is less than 12. Divide this by 4, divide this by 4, not 2, but 4. This will cancel this. We are still going to get now that k is less than 3. Life is great, brilliant. I hope that this is making sense to you guys. Once again, just as a reminder, please like the video, please subscribe to our channel, and most importantly, share the video with others.